Hello everyone, today we are going to talk about this lead code problem called 2 sum 2. Let's begin. So given a one index array of integer numbers that is already sorted in non-decreasing order, this is something important. Find two numbers such that they add up to a specific target. So here you have been given an array. You have to find two numbers in this array, the sum of which is equal to the target, which is equal to 9. For example, target is 9, so the sum of 2 and 7 is equal to 9. So in the output, you have to return the indices of these numbers. So index of 2 is 1, index of 7 is 2. So you return 1 and 2. So you have to assume that array indexing is starting from 1 here. So two important things to note in this problem statement before we proceed is the array is in sorted order. So you can see here, right? It is sorted. This is also sorted. So that will be helpful. We'll see how. And the second thing to note here is you must use only constant extra space. We're going to talk about it. Why this is relevant to this problem statement. So let us move to the solution space. So the first solution is the brute force solution. So let's see how to do it. So what you can do is you can start from this first element 2, and then you can iterate over the remaining array to check if the sum of this first element with other elements of the array is equivalent to the target. So for example, you have chosen 2 first. You check if 2 plus 3 is equal to 11, which is not. You check then is 2 plus 6 equal to 11, is 2 plus 8 equal to 11, or 2 plus 10 equal to 11. So none of them are 11. I mean the sum of none of these two element pairs is equal to 11. So you move to the next element. So you start with 3. Now again you check the sum of 3 with the remaining elements is 3 plus 6 equal to 11, which is not. Is 3 plus 8 equal to 11, which is true. 3 plus 8 is 11. So in the output you will return the index of this element, which is 2. We have assumed array indexing starts with 1, and at this position you got the sum, right? So you are gonna return 4. So this is the solution. But what is the time complexity of this algorithm? So the time complexity is order of n square. Why? Because you have iterated throughout the array, and for each element you again have iterated through the remaining array. For 2 you check the sum with all of these. For 3 again you check the sum with all of these. For 6 again you check the sum with all of these. So that's what the time complexity is. Now let's look at another solution. Another solution can be achieved using a hash table or dictionary or hash map, whatever you call it. So what we are gonna do is we are gonna iterate over the entire array, and suppose you are here at the first element. First what you have to do is check if this element is already existing in the hash map. So is 2 existing in the hash map? Nope, it is not existing in the hash map. So what you're gonna do, you're gonna subtract 2 from the target. So it gives 9. So you're gonna store 9 in the hash map, and in the value you're gonna store the index of this element. Index of this element is 1. Then again you move to the next element. So check if 3 is existing in the hash map. It is not. So 11 minus 3 is 8. So you're gonna store 8, and you're gonna store the index. Index here is 2. And then you come to 6. So again do the same thing. It is not there in the hash map, so 11 minus 6 is 5. Store the index together with it, so index is 3. And you come here at 8, but 8 is already existing in the hash map, right? So what you have to do is you have to return the solution. Solution is the value of this key value pair, which is 2, and the index of this element, which is 4, because the sum of the second element and this fourth element is equal to 11. So we have stored this element's position here, and this we can get while we are iterating. So this is the solution. But what is the problem with the solution? Okay, before moving to the problem statement, let's also talk about the time complexity. Time complexity is almost O of n, because searching in the dictionary is almost constant, and we have to iterate over this array as well. So that is of order of n. So that overall time complexity is again of order of n. What is the space complexity? So the space complexity is also of order of n because we are using a dictionary here or hash map. If you remember the problem statement, there were two things that we noticed. One thing is the array is in sorted order. Second thing is your solution must only use constant extra space. So if you're using a dictionary or a hash map, the uh, space complexity is not constant. So this condition is violated, so we cannot use a dictionary here. So we will talk about the third solution, which is the final solution, and we are going to use this property that the given array is sorted in ascending order or non-decreasing order. So let's see how we can leverage that. So what we are going to do is we are going to take two pointers. Take one here and the another one here. Now the array is sorted, right? This is something helpful. So first what you do is you check is the element at the two pointers. Okay, let me give them some names. Let me call it start and let me call it end. So check if the element at start plus the element at end is equal to the target, which is 11. So here 2 plus 10, which is 12, is not equal to 11, right? So the given sum is greater than the target value, okay? And this array is also sorted, which means if you have a solution in this array, then you have to take a value for the ending element which is lesser than 10, right? Because 2 is the smallest value and 11 is the target, and 10 is the greatest value in this array because it is sorted. So when you add 2 plus 10, you get something which is greater than 11. Now, why I'm saying that you have to take something lesser than 10? Because 10 plus 2 is 12, right? Now, if you take any other element in the array, the value will be always greater than 12 if you are replacing this 2. If you replace this 2 with any other value in the array, it will be always greater than 12. Why? Because the array is sorted, right? 2 is the smallest element. So increasing or replacing this 2 with any other value is something that we shouldn't do, because we already know that if we pick any other element in the array, the sum will not be lesser than 12. So what you should focus on, you should focus on decreasing this 10. Okay, so you keep 2 as it is and you decrease this 10. So what you do is you shift this ending pointer a bit below here. Okay, let me clean this. You shift this end pointer here. Now what is the sum? 2 plus 8 is 10. Now it is lesser than the array. I mean lesser than the target value, right? So again, by the same logic, if we replace this 8 with any other thing in the remaining array, 2, 3, 6, we're gonna get something lesser than 10, right? Because 8 is the largest value in this remaining array, because 10 we already have discarded now since we have moved one position back. So if you replace 8 with any other thing, you're not gonna get anything anything more than 10. So what you should focus on now is increasing this first element, 2, right? So you move this pointer here. So now you have 3 here. So what is the sum? 3 for this, 8 for this. This is 11, right? So you got the solution. So you just return the output indices, which is 1 and 4. So this is how two-pointer solution works. Now let us look at the code. Okay, let me increase the font size a bit. Oh, okay. I increased way too much. Okay. Now, so you have been given an array. Let's define the start as 0 and end as the length of the array minus 1. And what else you need? Okay, nothing else. Target is already given, so you can just start looping. So the condition is start should be less than end. You can also write less than equal to if the question says that you can have the same element twice in both the position. I mean, if if you have been given a value such as 14 here, and then you can do 7 plus 7. So if that kind of condition is given in the question, then you should write less than equal to. But nothing like that has been mentioned here, so I'll keep it less than. If I get an error, I'll make it less than equal to. Okay. Now what you have to do, you have to calculate the sum. So sum would be my element at start plus the element at end. And now we are gonna check. Let me decrease this more bit so it is more clear. Yeah. We're gonna check if the sum is equal to target. If it is equal to target, we are gonna just return the solution here only. So return new integer array, which is gonna have two values, start plus 1 and end plus 1, right? And what if sum is less than target? If sum is less than target, which means you have to increase the start pointer, else you have to decrease the end pointer, right? Now, since the problem statement says you will always have a solution, this will give us answers, but again, for the sake of not getting any compilation errors, let's return null here, but we'll never reach to this point as per the test cases. Let me try to run and see if there's any compilation errors. Nope, looks good. Let me try to submit. Super, it gets uploaded and it is succeeded. So that's all I had for this video, guys. Thanks for watching this video. Please like, share and comment. Thanks for watching. Bye.